So we've seen that judgments of probability all depend on the kind of order that nature behaves with, that nature expresses, and that unless we understand the probability of that order, of that scheduling, then we can't make any judgments at all about specific events. But this then leads to an even deeper objection to Hume's method, one that actually, ironically enough, Hume came up with himself. And that is the question of how I judge the background ordering itself. In other words, unless nature behaves in a regular way, all judgments of probability are null and void. Just because something happened a million times before doesn't in one whit make it more probable in the next moment, unless nature behaves basically in the same way. Let's call that principle the uniformity of nature. All probabilities depend on this. Now, what does that mean to say that nature is uniform? One way to put it is that nature behaves in the same way when I'm not looking at her as when I am looking at her. If that doesn't occur, again, no inductive argument, no probabilistic argument will work. Let me give you an example. Let's say I'm taking a poll. I want to know for the coming election how many people are going to support Joe Biden in the coming election. So I follow all of the scientific principles of doing a poll. I get a random sampling of people that's large enough to be representative of the constituents that are likely to vote. And I find that 60% of them, this is just totally made up number, say, of the ones I voted, say 100 people say they're going to vote for Biden in the coming election. That is only going to be a valid inference if what? If number one, that sample is really representative of the rest. In other words, that the nature I didn't observe is pretty much the same as the nature I did observe. And an even more particular fact, that after I asked the person, they didn't immediately change their mind. So what's the assumption behind a poll? That when I ask someone, their opinions are generally stable for a certain amount of time, but that amount of time is uncertain, has a expiration date to it, doesn't it? Because if we do the poll now, we won't think that poll is valid 2 years from now, because after all of the election fervor and different speeches and hearing the debates and stuff, we might change our mind. And so, what does a poll depend on? It depends on the relative stability of nature, that when I don't, things stay the same when I stop looking at them, or when I can't look at them. But now here's our problem. If, for example, all judgments of probability depend on this uniformity, ordering, and stability of nature, then I can't judge the probability of anything until I ask the question, how probable is this principle? How probable is it that nature is orderly, behaves in a uniform manner? I can't prove this, you see. I cannot prove it through logic. Why? Well, because there are examples when nature doesn't behave the way it does in my absence and in my presence. There's a well-known effect called the observer's effect, which means that in science we know that sometimes observations, especially with very small or fragile systems, are such that the minute I observe them, it changes the way they behave. And when I stop observing them, nature behaves differently. Now let's make that really radical. Obviously, I cannot prove, say I'm observing ducks. I want to see, okay, are all ducks in my neighborhood white? Or are there some black ducks? Well, I look around, I go everywhere in my neighborhood and I see ducks. And every duck I see, let's say, is white, and I observe hundreds of them. Now, of course, I have good reason to believe, you think, that ducks in general in my neighborhood are most likely white, and that most ducks are white. That's highly probable, unless this is what happens. Unless there's a little known effect that the minute I observe a duck to be white, that actually causes the duck to turn black 3 minutes after I stop observing it. So that, in fact, then, without knowing that, my inference would be totally incorrect, wouldn't it? I would then think most ducks are white, when in fact, the very act of observing it makes nature and the color of ducks unstable. And so what do I have to assume in observing mid-sized objects like ducks? That indeed, that nature remains stable in my absence. And so there's no logical proof for that, because there's nothing inconsistent with saying nature changes. And in fact, we have examples of it. But also, you can't use experience or observation to prove that nature is uniform, that it behaves in a regular manner. Why? Well, imagine what we would do in order to prove that. What we'd have to say is, we've observed nature over millions and billions of years, and in the way we've observed it, it's always behaved in the same regular pattern. Therefore, it will behave like that in the future. Isn't that our inference? We then have to say that what we've observed leads to what we haven't observed, don't we? In other words, we have to assume the very principle that we're trying to prove. We say, look, the principle of uniformity is proved in the fact that over all the centuries of our observation, nature has behaved in a regular, uniform manner. Therefore, it will continue to do so. But that inference will only be valid if what? If nature behaves in our absence the same way she behaves in our presence. And the future, by definition, is something we can't observe. And so therefore, it follows that we're assuming the very principle we're trying to prove every time we try to prove it by experience. The only way experience could prove that the future will be the same as the past is if we assumed that nature is uniform, and therefore it will behave in a way that the same way in situations which we can't observe, i.e. the future. And so we have a problem, don't we? We cannot prove this principle by our normal methods of either logic or experience. And yet all of our judgments about probability depend on this principle of uniformity. And the question thus for Hume is, you yourself are the one who came up with this problem. It was Hume in his book on the theory of knowledge that actually came up with this problem. And then he conveniently forgets it in his book on miracles, where he says, look, nature is really regular and therefore miracles aren't likely to occur. But he himself questions the probability that we could ever prove the regularity of nature through the very same reasoning that I am using here. So, how do I prove this principle itself? How do I prove that nature is probably regular? I can't prove it through experience. I can't prove, because all arguments from experience depend on it, and thus I'd be arguing in a circle. Neither can I prove it from logic, because there's no contradiction in denying this principle. In fact, we have plenty of examples through the observer's effect where nature doesn't behave the same way when we observe it and when we don't observe it. So in our next segment, what we want to look at is what Lewis says is the scientist's way of doing it. A thing called fit, general fit. When we judge not particular events, but the probability of a particular proposed order or theory of nature, we cannot judge it through experience or logic. We have to judge it through a more aesthetic means. And this itself, interestingly enough, opens the way to miracles, and also gives us a way of judging for any particular miracle, whether its intrinsic probability is high or low.